Next up, we're going to find the distance between 2 points, and one way of doing this is with what we call the distance formula. However, there, in my opinion, is a little bit much easier way to do this. So if we're wanting to know the distance from 3, 5, and I'm going to go ahead and plot these, 1, 2, 3, 1, 2, 3, 4, 5, and then 5, 9 would be somewhere up here. So in order to find the distance between 3, 5, and 5, 9, again, we're looking for this distance right here. To me, the easiest way of doing that is to imagine it as a right triangle. And if we could find the distance from 3 to 5, that tells us the bottom side of our right triangle. And the distance from 5 to 9 tells us the top side of a right triangle. And then instead of actually using the distance formula, which is just derived from the Pythagorean Theorem, we can just use Pythagorean Theorem itself. Again, we simply found the distance from 3 to 5. That gave us one length. The distance from 5 to 9 is the other length. And then we're going to use the Pythagorean Theorem on that. Again, what I like to do is I like to shrink the sides. Instead of using 2 and 4, using 1 and 2, and find that missing side, and then scale it back up. So then we have 1 squared plus 2 squared equals c squared, or 5 equals c squared. To get rid of a square, we square root. So the square root of 5 is going to be the missing side there, but then once we scale it back up by multiplying back by 2, we find the distance between those 2 points is 2 root 5. Now let's try to work one more example, and I'll just make up one right here real quick. -3, 8. Up to -6, -1. Again, first step, we find the distance from -3 to -6. And you can think of that on a number line as how far is it between these two numbers, and that's simply a distance of 3. How far is it from 8 to -1 would be a distance of 9. And again, we're trying to find that c value. Again, if you will shrink those values down by dividing by 3, gives you a 1 and a 3, and we're finding that missing value. Applying the Pythagorean Theorem, a squared plus b squared will give you a value of 10 equals c squared. To undo a square, we square root, which gives me a missing side length of 10. Once I scale that back up by multiplying back by 3, we find the distance between these 2 points is 3 root 10. Next up, we'll show you how to find the midpoint of a line segment given the 2 endpoints. And we see here the midpoint, again, the middle point is what we mean by that would be somewhere right in here. And in order to find that midpoint, what do we need to understand? The midpoint, if you were to look at it, the midpoint is going to lie directly in between the 2 x values and directly in the middle of the 2 y values. So another word for midpoint, the word that we need to remember that is synonymous, that goes along with midpoint, is the average. Because the average of 2 numbers is the number that's right in the middle of those 2 numbers. So if we had these 2 points, and let me put some numbers with this. Let's say this is my origin here, so this would be the point 1, 2. That makes the other point, let's see, 2, 3, 4, 5, 6, 7, 3, 4, 5, 7, 5. So anytime we're looking for the midpoint, the easy way is taking the numbers 1 and 7 and simply average them. Add them, if you don't remember. To find the average, we add them and divide by 2. So that's going to be 8 divided by 2, which is 4. And the midpoint could contain decimals, like 2 plus 5 is 7, but when we divide that by 2 using our calculators, we actually get 3.5. So this point right here in the middle would actually be the point 4, 3.5. So again, with that said, anytime that we're given 2 numbers, and I'll just make up a couple of numbers here, 3, 6, and -5, -1. In order to find the midpoint, we simply add the x values together and divide that by 2, and that gives me a value of -1. Add my y values together, that gives me a 5. When we divide that by 2, it gives me 2.5. So my midpoint would be located at -1, 2.5.